Hi, this is Harry again. This is the third in a four-part series answering the question, what is science, based on the items of the Nature of Science quiz developed by Larry Flamer. So in this clip, we'll be looking at these 5 items here. The first item here is quite an interesting misconception that a lot of people have, that science is an uncreative process, when actually creativity is required at every step of the scientific process. The formulation of a hypothesis requires researchers to brainstorm or find in the literature all possible independent variables that could affect the phenomenon they are studying. Quite often, novel experiments then have to be designed to test this hypothesis, and a multitude of decisions made as to how to control controlled variables and measure dependent variables. Once the data is collected, decisions must be made as to how to analyse and represent the data, but more importantly, how the data will be interpreted, how it relates to previous findings on the topic, and what it means for the future of the field. Actually, science is a complex interaction between 4 broad methods. These are descriptive, modelling, theoretical, and experimental methods. So let's have a look at each of these in turn. Within the descriptive methods, these are scientists who go out and describe the world and whatever is in it in minute detail. So you might be a botanist or an entomologist or even an astronomer who discovers a new star or a planet or a plant or an insect or a microbe, and you describe these in minute detail. Or you might be a chemist who discovers a new drug, then you go on to describe the chemical structure, its boiling point, its melting point, its other physical properties, the reactions that it's capable of, and perhaps adverse reactions that might occur when somebody takes it. Then there's the modelling sciences, and these are most often related to meteorology and climatology, but you might also be an engineer who looks at racing cars or aeroplanes and use complex mathematical models to test new designs within a wind tunnel or a virtual wind tunnel, as you can see there. So these scientists use mathematical equations to represent the weather or climate respectively, that is with meteorology and climatology. They can't do experiments in the traditional sense, so they check their models by seeing how well they match the known data, or by backcasting, and how well they predict the future, which is forecasting. Then there's the theoretical methods. So for example, Stephen Hawking is a theoretical scientist, but also Peter Higgs and Sheldon Cooper. They're all theoretical scientists. So what these guys do is they use mathematics to develop new theories, which then an experimental physicist will then design an experiment to test. Another example is Einstein. So Einstein's theory of general relativity couldn't be tested for 50 years because we didn't have the technology to do so. But now their understanding has allowed us to develop GPS and then actually enable our smartphones to work. However, the queen of all methods within the sciences are the experimental methods, and eventually all claims must pass through these methods if they are to be deemed science. Experiments were a key innovation which made science so successful in explaining the universe compared to other ways of knowing, such as history and philosophy and theology, because it allowed scientists to establish causality with ever-increasing confidence. It allowed scientists to establish causality by isolating and controlling variables and measuring the effect of that change on another variable whilst holding all others constant. So for example, it allowed scientists to pin down that microbes were the cause of infectious disease and not curses, immoral behaviour or bad air. It allowed scientists to show that we actually live in a quantum universe. It showed us how to control the electromagnetic force to give us radio, television, movies and electricity, and allowed us to understand the forces of flight to give us aeroplanes, rockets, and eventually put a man on the moon. Science, far and away, is humanity's best invention for investigating how the universe actually works. So while many other fields of knowledge have description, so for example history, or modelling, for example economics, and theorising, for example philosophy, experimentation is unique to science. Let's have a look at this question here. Knowledge of what science is, what it can do and cannot do, and how it works is important for all educated people. Many of our current problems could have been prevented or reduced if political leaders, business leaders, and a voting public recognise how good science is done and how its reliability is measured. The growing and undeniable evidence of man-made global warming over natural warming has been strongly and increasingly supported by scientific studies. Too many people in power, and most of the general public, who could have created pressure, have simply not understood the benefit of and power of science. Many people try and discredit science or only look at few studies that seem to fit their own vested interests or political leanings, and ignore the vast majority of scientific studies that clearly show how our world is changing before it becomes obvious to everyone. We see this in quack medicine and many other frauds and pseudosciences that can be spread even faster now via the internet. Without knowing the nature of science or how to critically analyse evidence, most of the world's citizens are at the mercy of hucksters. So the take-home message from this clip is that science involves many methods, that science is a creative process, and experimentation is unique to science. So here's a few words by Neil deGrasse Tyson.